Imagine a future where the vast expanse of space isn't so vast after all. A future where the cosmos is closer than ever before, thanks to the ingenuity and daring spirit of humankind. This isn't the realm of science fiction anymore. This is the dawn of a new era in space exploration. Today, we're going to traverse the limitless bounds of imagination and science, delving deep into 5 futuristic concepts that could revolutionize space travel. An adventure that begins not light years away, but right here, right now. Before we launch into the details, if you're intrigued by the endless possibilities of the cosmos and our place within it, then be sure to smash that like button, subscribe to our channel, and prepare to have your mind propelled into new galaxies of thought. Our first concept is a marvel of engineering, a space elevator. Picture this. A ribbon-like structure stretching from the Earth's surface into geostationary orbit, a counterweight in space keeping the structure taut as climbers ascend and descend, transporting materials and astronauts into space without the need for explosive rocket launches. The core of this idea lies in carbon nanotubes, a material stronger and lighter than any we've used before. Though the technology for such an undertaking isn't quite within our grasp just yet, scientists and engineers around the globe are working tirelessly, making incremental advancements towards making the seemingly impossible a reality. The implications of a space elevator extend far beyond the reaches of convenience. It's about shattering the cost barrier to space that has loomed over us for decades. Imagine launching satellites, telescopes, and even colonization missions to other planets at a fraction of the current expenditure. We're talking about giving birth to a golden age of space travel, where the universe becomes our backyard, tantalizingly ripe for explorative endeavors. But challenges stand firm in the way. Atomic oxygen erosion, space debris hazards, and the sheer engineering feat of constructing a structure beyond our current tallest buildings. Transitioning from the concept of reaching space to traversing it with unprecedented speed, let's dive into the second concept, the elusive and hotly debated warp drive. The boundaries of space and time have always been the ultimate constraints of human exploration. But what if we could bend the very fabric of the universe to our will? Warp drive isn't about traveling fast. It's about making distances irrelevant. The idea is so revolutionary that even Einstein's theories would tip their hat in acknowledgement. A warp drive would utilize the manipulation of space-time itself, contracting it in front of a vessel and expanding it behind, propelling the ship faster than light could ever hope to travel. This isn't just about breaking the light speed barrier. It's about creating a cosmic shortcut. As we discuss this, teams of physicists are feverishly poring over their equations, looking for a breakthrough that could turn this sci-fi staple into a scientific reality. It's a monumental challenge that requires exotic matter, negative energy, and a mastery of quantum mechanics we've yet to achieve. But the potential is as boundless as the universe itself, reaching neighboring stars within a human lifetime, unlocking the stories hidden in distant worlds, and maybe, just possibly, finding the answers to the questions that have haunted our species since we first gazed upward at the stars. From the bending of reality to the splitting of atoms, our third concept harnesses the power locked within the nucleus of an atom: nuclear propulsion. While traditional chemical rockets have served us faithfully, the future of interplanetary and, dare we dream, interstellar travel lies in the vastly more efficient and powerful realm of nuclear energy. Two flavors tantalize the taste buds of aerospace engineers: nuclear thermal propulsion, NTP, which heats propellant to extraordinary temperatures before expelling it to generate thrust, and nuclear electric propulsion, NEP, converting nuclear energy into electrical power to drive ion engines. The efficiency leap from chemical to nuclear is not incremental, it's exponential. We're looking at propulsion systems that could, in theory, keep spacecraft cruising through the void for years, perhaps even decades. This isn't merely about speed, it's about sustaining human adventurers far from the haven of Earth, on voyages that will rewrite history and expand the human frontier to outer worlds. The obstacles in our path are not inconsiderable, ranging from engineering challenges to the safe handling of radioactive materials in space, but the blueprints are being drawn. Nuclear propulsion may well be the key that unlocks rapid and repeated travel through our solar system, and maybe, one day, to the stars themselves. As we reimagine our starships, we must also reconsider where and how we build them. Our fourth concept redefines construction as an extraterrestrial endeavor, on-orbit manufacturing and assembly. Gone are the days where every nut and bolt of our spacecraft must first bear Earth's gravity before breaking free. Advancements in robotics, 3D printing, and autonomous systems are setting the stage for a future where spacecraft emerge, phoenix-like, in the very environment they are destined to explore. Imagine shipyards in the sky where materials sourced from the moon or asteroids are fed into massive printers, layer by layer, crafting vessels tailored for the void. These structures could be enormous, unfettered by the constraints of Earth's gravitational pull, perfectly designed for their cosmic voyages. This isn't just about convenience, it's a paradigm shift in the economics of space travel. The challenges we face are immense. Microgravity manufacturing processes, autonomous assembly in a hostile environment, the logistics of space mining. But the rewards promise to be greater still. We've ventured from Earth to the stars, but what of the journey within? Our fifth concept grapples with an aspect of space travel that's often overlooked, yet is crucial for long-duration missions: artificial gravity. The human body evolved under the constant pull of Earth's gravity, and its absence creates a maelstrom of physiological changes, muscle atrophy, bone density loss, and cardiovascular alterations, to name a few. But what if we could mitigate or even eliminate these effects by replicating Earth's gravitational pull? Centrifugal force could be our artificial gravity well, creating habitats where floors push against feet, providing the reassuring sensation of down. Rotating spacecraft and ring habitats offer a glimpse of such a future, where astronauts can live and work in environments conducive to long-term health. The research is ongoing, the designs proliferating, and slowly but surely, the dream of sustainable human life in space draws closer to reality. These 5 concepts are not mere flights of fancy. They are the pinpoints of light in the darkness, guiding us towards a future where space travel is commonplace, where the cosmos is not merely a destination, but our home. As we contemplate these remarkable visions of tomorrow, tell us, which of these 5 concepts excites you the most? Share your thoughts, and let's have a conversation that spans across planets and possibilities. And remember, if you're fascinated by the future of space travel and want to keep up with the latest developments, don't forget to like, share, and subscribe. Together, let's embark on this celestial journey of discovery, where the only limit is our collective imagination.